Hey, happy Winning Wednesday. I'm going to call it a Winning Wednesday because I'm in a really good mood and I feel like I'm just going to win at everything I do today. And I want you guys to feel that through the computer so that you will be energized and feeling the same way so that we can get through Number Corner and we can learn something and have fun at the same time. So welcome to today's Number Corner. Today is January 6, 2021. Today we are going to look at all the calendar markers from January 1st until today the 6th and see what kind of pattern we have going on this month. Let's see. Now, when I turn these cards over, I just want you to make some observations to yourself, all right? Day 1, January 1st. And I will say that each one of these squares is worth 1 square unit, okay? January 2nd. Interesting. January 3rd. Okay. January 4th. January 5th. And today, January the 6th. Okay, what can you tell me about these shapes? If I were to ask you to just make some generalized observations, what would or could you say? Yeah, we have rectangles, triangles, and parallelograms. Absolutely correct. Let's look at our calendar grid observation recording sheet. And I will say that this month we are looking at shapes, obviously. And I'm going to toss out the word shapes that are similar. So let me go back a slide. Shapes that are similar, they're going to have the exact same shape. They're going to be different sizes. And just to throw in something extra, when it has the same shape, yes, it's different size, but each side is going to increase by the same ratio. So if you see this, I know it's kind of small, it's 1 centimeter here, and then it goes to 2. So it's multiplying by 2 in essence. And then this side length goes from 2 centimeters to 4 centimeters. It also multiplies the length by 2. So those shapes are similar. Hopefully we know congruent. That means they're the same size and the same shape. So when I'm asking you to make observations, these are some of the math vocabulary words that I'm looking to hear from you guys. We already talked about a parallelogram. It's a flat shape, 2D shape, 4 sides, and they're both pairs of opposite sides are parallel. Here we have some of the different types of triangles, and you may already notice what type of triangle we've seen on one of our calendar markers so far this month. So I'll give you a moment to look at that, and then I'll switch back to the next sheet so we can make our observations and write them down. All right, so we know we have rectangles. Now we know that the shapes are similar. They are similar because they are the same shape, just different sizes. So we already named our shape names. So I'm going to remove this here because I've already filled it out for you guys. We have rectangle, rectangle, triangle, triangle, parallelogram, parallelogram. And I was actually really specific, and I called these triangles right triangles because a right triangle is going to have a right angle on one of the sides, okay? So it's a right triangle, and maybe we can even go a little bit further and say that it is an isosceles triangle. We don't know that for sure until we were to measure. So I just put a right triangle, but I think so because this is 1 and this is 1. So I could write isosceles, right triangle. And you know what? I think I'm going to do that just for the sake of using our math vocabulary. Isosceles. I spelled that correctly. Let me just double check. Yes, I did. All right, so now let's talk about the area. You may remember I already gave you one hint, and I said that the area of one square is one square unit. So, looking at our first marker, how many square units do we have? Does it fill up one whole? No, it doesn't fill up one whole. It only fills up half of the square unit. So it has an area of 1/2. If I were to type up observations about this shape, I could say it doesn't fill the whole area, possibly. And we already know that it's a rectangle, so I will leave it as that. All right, so then now, how about this one? What is the area of this one? Yeah, we have 2 of our square units filled in, so that means it has an area of 2. And we could say, what about the shape? Are you using that math language? If you are, that's awesome. It's similar to, I'll put January 1st. Same size or same shape, different, and I'm going to abbreviate here, different size. That's what similar means, just to remind you. All right, then we have our triangle here. What do you think our area is going to be for this shape? Yeah, it is also 1/2 of a square unit because it does not fill the whole area. So I can put, again, doesn't fill the whole area. Right, and then for our isosceles right triangle, we have one full square unit here, 1/2 plus 1/2, right, which gives us 2. And I can put, this time I'll put it is similar to January 3rd. Similar to January 3rd. It's just bigger, okay? All right, what about our area for our parallelogram here? So we have 1/2 here and 1/2 here, which gives us a total of 1 whole square unit, right? 1 whole square unit, and let me bring this down just a little bit. 1 whole square unit, and while I'm here, let's just go ahead and figure out the area of the 6th. 1, 2, 1/2 plus 1/2 would be 3, 1/2 plus another 1/2 would be 4. So this has a area of 4. So 1/2, 1, 4. Wonder if that's creating some kind of pattern. What observations can you make about the parallelogram? Right, it takes up half, I'll just put 2 halves. How about that? 2 halves, which make a whole. Make sense? Yeah. And then, of course, this parallelogram is similar, that's our word for today, to January 5th. It's bigger. Bigger in size. But it's the same shape. Okay, now just to go back and clarify again, last time we talked about how when we're doing our calendar collector, we are doing calendar collector for each day we are in school. So Ms. Travell had it wrong on the first day. So I do want to refresh your memory. Here was our first day in white. Our second day was in yellow. And now we're on our 3rd day of school for January, and that's in white. So how much money do we have all together? $1, 25 cents. So we have $2.25. And you see here, some of the fractions are already filled out because each day we're collecting 3/4, which is 3/4. So 3/4 Okay, and then on the second day, we add another 3/4. So 3/4 plus 3/4 is 6/4. And we could see it was having a whole dollar plus a half of another dollar. So that's 1.5. And now we have, I'm gonna put that as 2 whole dollars, 2 1/4, because a quarter is a fourth of a dollar. Are we good? All right. Now, our last activity for today, which I think is going to be kind of fun, is we're going to be putting some fractions on a number line. Now, this kind of goes back to, I think it was September, maybe October, where we were collecting 6 inches a day. But I had to scale it down to size so that it would fit on the computer and you could see it and you could see it clearly. So this number line right here is representing 1 foot. 1 foot, which is the same thing as saying 12 inches. Okay? Normally I would ask you to make observations about that before telling you, but I wanted to just make sure it was very clear about what's happening here before we go any further. Okay? Okay, so 1 foot, and it is 12 inches, so let me make sure I got this lined up perfectly here. And we're going to start by putting some fractions on this number line. We are going to start with the halves, and we're going to label halves in blue. So I'll put this ruler above the number line just to make some relationships between measuring conversions. We've done measurement conversions already, but it might also help us with labeling our fractions, okay? I want to put half. Where would the half go? Yeah, 6 inches, because half of 12 is 6. And if we didn't have that there, we would have to kind of estimate as best as we can by saying that half of the, we'd have to estimate and say that we'd have to put it in the middle of the line, which is what I'm trying to do without making too many changes to my number, but that's not working out for me so well right now. So let me fix that. All right, so I was able to move it to the 6. So now we have labeled our half, and we have another half here. Right, 2 halves. Where would I put 2 halves? Yeah, same as 1 whole. So let's move our 2 halves. And I messed it up again. Okay, here we go, and I'm going to line it up really as even as possible with our 1 whole. All right, we good? All right, now since I know my halves, maybe I can label my fourths. So let's do that. See if you can draw a number line in your notebook and identify where the fourths would go. All right, so what do we know about fourths? Okay, a fourth is half of a half, right? I would take a piece of paper and I fold it in half. In order to get fourths, I'd fold it in half of again. Or I can think about my 12 inches and divide it by 4, and I'm going to get 3 inches in each fourth. So I'm going to take my first fourth. Possibly, maybe. And I'm going to move it to 3 inches. And you can see my red line here is really trying to help me stay true to where it's supposed to be. Okay, so that's 3 inches, right? Where would I put 2/4? Right, 2/4 is equivalent to 1/2. So I could put 2/4 right underneath the half, right here. line it up nice and or as perfect as I can be. How about 3/4 then? If 1/4 is 3 inches, 2/4 is 6 inches, how many more inches do I have to add for another fourth? Another 3 inches, which would give me, right, 9 inches. So I'm going to put my 3/4 right here. And lastly, I have 4/4, which also is the same as 1/2. So I can move my 4/4 here to line it up. Perfect. All right, let's do the same thing for 8s. Take a moment and think. How am I going to figure out 8s? What method would you choose to use? Great. An 1/8 is a half of a fourth. So what is a half of a fourth? A half of 3 inches would be what? Some of you may have taken 12 inches and divided it into 8 equal pieces. You could do that. What would you get though? Yeah, 1.5. So 1/8 is the same thing as saying 1.5 inches. Try to line that up as best as possible. All right, do we see that? Okay, so then 2/8 would be 1/2 plus 1/2, which is 1.5 plus 1.5, which is 3 inches, and it's equivalent to 1/4. So hopefully you guys are thinking about equivalent fractions, and maybe that's helping you. All right, how about 3/8 then? 3 inches plus 1.5 inches is 4.5, which is halfway in between 1/4 and 1/2. So then 4/8, easy, Miss Tramell, right? That's equivalent to a half. Very good. And we can go ahead and say 8/8, skip ahead, and say 8/8 is equivalent to 1/2, because we know that. So what about 5/8, 6/8, and 7/8? Good. 5/8 would be 7.5. Oopsie. Let's try that again. 5/8 is 7.5. 6/8 is equivalent to 3/4, which is 9 inches. So I took 1.5 and I multiplied it by 6. 1/2, another half is 3, plus another 3 is 6, plus another 3 is 9. So 9 inches. And that makes 7/8 belong where? Awesome. Halfway between 3/4 and 1, which is 10.5. Now I want you guys to use this number line to answer some questions. Okay, let's look at some of these questions. How many fractions are equivalent to 1/2? We know there are a lot of fractions equivalent to 1/2, so we're just going to focus on what we have listed on our number line so far. How many? 3, good. Well, really 2 are equivalent to 1/2. 1, 2. Okay. How about 3/4? Right, it has 1 equivalent fraction. 8/8, 2. All right, can you think of a fraction that's equivalent to 1/4 that's not on the number line? 1/4, 2/8, 3, 3/12. Yeah. All right, so using this number line, it should be very easy to tell which one's bigger. So is 5/8 bigger or is a half bigger? And by bigger, we're looking at farther distance on the number line. Good, 5/8. So is 7/8 or 3/4 bigger? 7/8. Which is smaller, 3/8 or 1/2? 3/8. How about smaller between 3/4 or 6/8? Ooh, they are the same. You guys did a great job today. We're actually going to stop there. Maybe we'll do some more work with fractions on the number line later this month. Have a wonderful rest of your winning Wednesday. Make it a great day. I'll see you guys tomorrow. Bye-bye.